All right, let's just jump right in. We're going to talk about an animal that looks like it was literally made for viral videos, but it's hiding this just wild secret behind those huge, innocent-looking eyes. I mean, you've seen these guys online, right? The slow loris. They're these small, furry creatures with those gigantic, soulful eyes. They have this really slow, deliberate way of moving, and you just instantly think, oh, what a gentle, harmless little thing. And yeah, for sure, they're one of the internet's absolute darlings. Okay, but here's the twist. What if I told you that that super adorable face belongs to one of the only venomous primates on the entire planet? Yeah, you heard that right. This cuddly little guy packs a seriously toxic punch. So the big question is, how? And maybe even more important, why? So let's pull back the curtain on this cute but, wow, incredibly complex animal. This isn't just some random trivia night fact. No, this is a deep dive into some really sophisticated evolutionary biology, a story that's unlike almost anything else out there. Okay, so the first thing you need to know is that this isn't like a snake or a spider where it's just bite and you're done. The slow loris has this amazing two-step venom system. And get this, it's the only one like it ever discovered. It actually has to prepare its venom before it uses it. It all comes down to two key ingredients. First, you've got this special oil. It's called Brachial Gland exudate, or BGE for short, and it comes from a little gland on its upper arm. Then, you've got its saliva, which is also pretty specialized. Now, on their own, neither of these is a huge deal, but when you mix them together, whoa, you get a seriously potent toxic cocktail. So here's how the whole process goes down. It's a four-step deal. First, that gland on the arm secretes the oil. Then, and you might have seen pictures of this, the loris does its famous venom pose, raising its arms up over its head so it can lick the gland and scoop up that oil. Step 3 is where the magic happens. The saliva and oil mix, and boom, the venom is activated. And for the grand finale, a bite from its special tooth comb injects the fully loaded venom. Okay, hold on, because this is where the story gets really weird. I mean, truly bizarre. When scientists started breaking down the chemistry of that arm oil, they found something completely unexpected, a connection to a totally different animal, one that many of us have in our own homes. It all boils down to one specific protein in that oil. We'll just call it BGES. Now, it belongs to a family of proteins, but what's crazy is that this specific one has a nearly identical twin. And it's a twin you're probably way more familiar with than you realize. Okay, get ready for this. On one side, you have the loris venom protein. On the other, the FELD1 protein. And if that name sounds kind of sciencey, let me break it down. That is the main protein that makes people allergic to cats. I'm not kidding. They are so similar, both in their structure and what they do, that it is just a mind-blowing example of what we call convergent evolution. I mean, just think about how wild that is. You've got two mammals that are not related at all, a primate from Asia and your house cat, and they both evolved to make almost the exact same protein. One uses it for venom, and the other, well, we know it is the thing that makes us sneeze. It just opens up this huge, fascinating question. What's the real connection between venom and allergies? And this isn't just a science curiosity. This has real-world dangerous results. This strange similarity is probably why a bite from a slow loris can send someone into anaphylactic shock. Their immune system just goes haywire, exactly like a really bad allergic reaction. Some scientists even think if you're allergic to cats, you might have a worse reaction to a loris bite. And as if that's not enough, their saliva also has another protein that can directly trigger inflammation in our bodies. Okay, so we've got the how. We know how the venom works, but that leads to the biggest question of all, right? The why. Why on earth did this tiny primate develop such a sophisticated and dangerous weapon? It's not really for hunting, and it's not mainly for fending off huge predators. The real answer is a lot more personal than that. Just look at this chart. It's pretty telling. A whopping 70% of the time, that venom is used for what's called intraspecific competition. Fancy term, but it just means they're fighting other slow lorises. Then you've got about 25% for dealing with parasites, and defending against predators, that's way down at the bottom, only 5%. So here's the bottom line. The number one reason for this venom is to win fights. And we're talking brutal, knockdown, drag-out fights with other lorises. These brawls are for territory, for mates, and they can be incredibly vicious. The venom causes these deep wounds that just refuse to heal. And yeah, a lot of the time, these fights are fatal. And you can see the proof right on their bodies. I mean, scientists looking at wild Javan slow lorises found that more than half the males, 57%, had bite wounds. It was pretty much the same for Sumatran slow lorises, over 52% of males. So this isn't some rare freak event, it's a core part of their life. But the venom has another really important job. Slow lorises will actually spread this toxic mix all over their fur and even onto their baby's fur. It basically becomes this powerful chemical shield, protecting them from nasty parasites like ticks and fleas that are a huge pain for lots of other primates. And how well does it work? Oh, it's incredibly effective. In one study, when scientists exposed a bunch of different insects and things to the venom, 76% of them were pretty much knocked out instantly. It's like they're wearing a coat of super potent, all-natural bug spray. All right, so we've got venom for fighting and venom for parasite control. Two pretty solid reasons. But there's one more layer to this whole defense system, and honestly, it might be the most mind-blowing part of the entire story. It's this incredible theory about evolutionary mimicry. And just look at the evidence side by side. The similarities are just uncanny. You've got the stripe down the loris's back that looks a lot like a cobra's hood markings. They both do this slow swaying thing. They both hiss. And that venom pose we talked about with the arms up over the head, it looks almost exactly like a cobra rearing up and flaring its hood. It's like the loris isn't just venomous. It's pretending to be one of the most dangerous snakes around. Now, something like this doesn't just happen overnight. This is the result of an ancient evolutionary arms race. You have to imagine, millions of years ago, as lorises were spreading across Asia, they were sharing their forest with all kinds of deadly snakes. That constant threat probably pushed them to evolve these cobra-like defenses. And here is the absolute kicker, the proof in the pudding. Modern slow lorises have a built-in genetic resistance to snake venom. How cool is that? So let's just do a quick recap of this wild ride. The animal we all thought was just a cute face is actually one of the world's only venomous primates. It cooks up a unique two-part venom, using arm goo and saliva. Bizarrely, that venom has a protein that's almost a perfect match for the stuff that causes cat allergies. It uses this stuff mainly to fight other lorises and as a personal bug repellent. And for its grand finale, its ultimate defense might just be pretending to be a cobra. It is just such an incredible story of evolution, right? And it really leaves you with this one big thought. If this creature we all thought was so simple and harmless is secretly pulling off this complex imitation of a deadly snake, what other amazing, profound evolutionary secrets are hiding out there, right in plain sight, just waiting for us to notice?